Ask anyone to describe Amsterdam city centre, and the historic canals with bridges and quays are likely to be part of that description. In past and present time, this canal system has been a vital element of the city's infrastructure. It is part of Amsterdam's DNA. Today, however, there are many unknowns about the state of the city's bridges and quays. How much load can they still handle?
A couple of years ago, the city faced some incidents, for example on the Nassaukade and the Marnixkade. In the past decades, the maintenance has been partly neglected. In this period, the use of the infrastructure has increased significantly. We started a program on bridges and quay walls, and we focus on the 850 bridges for heavy traffic and 200 kilometers of quay walls. At this moment, on the most weakest spots, we take some safety measures in reinforcing structures. We really want to work together with science to develop new techniques that we need to face these large problems.
All these quay walls are constructed in the same way. So we have these rows of piles placed, let's say, 1 meter apart from each other. And on top of that we have a timber deck which supports the soil which we are walking on, and the road system, etc. And then at this side of the quay wall, I would say around 5 meters from the waterfront, we have an earth retaining screen which prevents the earth from sliding into the water. And the canal walls as we know them, the brick walls, they are placed at the waterfront to prevent the road to collapse inside the canal. Because these quay walls are so old, some are 200 to 300 years old, there's poor documentation, and therefore a lot is uncertain about these quay walls. The load was designed for horses. At some point the load becomes larger than the resistance of these quay walls. The research is to get a better picture of the reliability of these structures and also to improve the knowledge about the actual behavior of these structures. So how do they collapse? What are the failure mechanisms that we have to look for? What we actually want to achieve with modeling is that we want to copy the exact behavior of a quay wall and say something about the actual strength of them. And this can help us by the assessment of prioritizing which quay wall section we have to replace or which we can stay around for 20 more years.
So the challenge is that we have to deal with the bridges and quay walls right away because the city has to be safe. That's the most important challenge that we are facing now. But that doesn't mean that at the same time we cannot look at the bigger problems that we face as a city. So how we organize that is that we have project teams that are dedicated to making sure that the bridges and quay walls are safe and strong enough for usage. And at the same time we have living labs in which we can slow down a little bit and look at new solutions. So what we are looking at now is with these challenges such as circularity, climate adaptation and energy transition, how we can combine functions. An example of integrating these types of functions is looking at generating energy or collecting heat from the canals through the foundation poles of quay walls. We haven't tried that yet, but this is something that we're working on to see how that would work in practice.
One of our first activities is that we try to establish a research agenda, and that is about monitoring, it is about assessment, it is about life rejuvenation, it's about renewal and about the building logistics in the city. We made a proposal to the Dutch Research Council, the NWO, together with the engineers from the city and together with the businesses involved in the renovation of quay walls. The questions from the municipality and from the businesses also guarantee that we will have a lot of impact with our research.
In our research, we aim to improve our understanding of the structural and shallow subsurface conditions affecting the behavior of historic quay walls to make sure the quay walls of Amsterdam are once again future-proof.